We're absolutely surrounded by data, but getting answers from that data often means you have to learn a whole new language just to ask a simple question. So, what if? What if we could teach AI to be our universal translator? Today, we're diving into the incredible quest to do just that.
It really seems like it should be a simple thing, right? You've got a question, the database has the answer. Easy. But as you probably guessed, the reality is, well, it's a little more complicated than that. And this slide, this just illustrates the problem perfectly. On the left, you've got a totally normal question a human would ask. On the right, that's SQL, the language databases actually understand. Now, it's incredibly precise, it's powerful, for sure, but it is not intuitive. There's this huge gap between how we think and how machines need to compute. So the dream, the big goal here is to build a bridge right across that gap. To create an AI that lets anyone, doesn't matter if you're a CEO, a researcher, or just curious, simply ask a question in plain English and get an answer without ever needing to see a single line of code. This brings us to this fascinating field of AI research known as natural language to SQL, or as you'll see it, NL to SQL. Its whole purpose is to solve this exact universal data challenge. So the key takeaway here is that NL2 to SQL is all about automated translation. It's about taking that nice, simple question on the left from our earlier slide and having an AI automatically and, more importantly, perfectly write the complex code on the right. But as you can probably imagine, getting it perfect, that's the really hard part. See, the early AI translators, they weren't perfect, not by a long shot. They'd often make subtle but significant mistakes. And this led to the first really big breakthrough in the field, teaching the AI to catch and correct its own errors. A great way to think about these first-generation models is to picture a brilliant but super literal intern. You know the type. They're smart, they follow instructions to the letter, but they can totally miss the subtle context and end up making these small but critical mistakes in the final SQL query. So, how did researchers solve this? Well, a framework called Text-to-SQL came up with this really clever feedback loop. Okay, follow me on this. First, the AI translates the question into SQL. Simple enough. Then, it actually runs that SQL to get an answer. But here's the magic step. It then translates the answer it got back into a plain English sentence, and then it compares that sentence to the original question. If they don't mean the same thing, the AI knows it messed up somewhere and it starts the whole process over. It literally checks its own homework. It's brilliant. Okay, but what if one AI, even one that can self-correct, just isn't enough? Well, the next big evolution in this field was what's called the ensemble approach. Basically, getting a whole team of AIs to tackle the problem together. The real challenge, though, as this quote from the Text-to-SQL paper points out, is that just having a bunch of AIs generate a query and then voting for the most popular one, that doesn't always work. The most common answer isn't always the right one, especially when you get into really complex questions. And that's where frameworks like Text-to-SQL have just completely pushed the boundaries. I mean, you can see from its performance across all these different benchmarks, this method is incredibly effective. It doesn't just take a simple vote. It uses a multi-generator ensemble. Think of it like a team of different experts to generate, refine, and then intelligently select the best possible answer from a whole pool of diverse candidates. The route method gives us a fantastic look inside how this collaborative process actually works. It's not one giant step. It's a sequence of specialized tasks. You have a specialist in what's called schema linking that first identifies the right data tables. Then a text-to-SQL model generates the initial query. After that, a noise correction module comes in and acts like a proofreader, checking for common mistakes. And finally, a continuation writing expert can step in to finish or rewrite the really complex parts. It's like a finely tuned assembly line of AI specialists. All right, so we have AIs that can self-correct and AIs that can collaborate in a team. But there's another really crucial layer here: trust. How do we build systems that know when they don't know the answer? I mean, just think about it for a second. In a real business setting, an AI that gives you a wrong answer but says it's 100% confident, that is way more dangerous than one that says, hey, I'm only about 60% sure on this, you might want to double check. That uncertainty, it's a feature, not a bug. This whole concept is called calibration. It's all about making sure that when an AI says it's 95% confident, it's actually correct about 95% of the time. A perfectly calibrated model has a healthy sense of self-doubt, which is exactly what you want when you're making important decisions based on what it's telling you.
But sometimes the problem isn't the AI's confidence at all. It's the very data it learned from. This example from the SQL Driller paper is just fascinating. The question asks for all aircraft and how many flights they've had. The training data, the textbook the AI studied, used something called an inner join, which completely misses any aircraft that have never flown. The correct answer actually uses a left join. So tools like SQL Driller are being designed to automatically find and fix these hidden errors in the training data itself. It's like proofreading the AI's textbooks before it even starts class.
So this all leads us to the final and maybe the most important piece of this entire puzzle, bringing the human back into the loop. Because out here in the real world, we have to deal with constraints like cost and, the beautiful messiness of human language. Take this chart, for example. It plots accuracy against cost. The state-of-the-art models are way up there in the top right. They're incredibly accurate, but they are also crazy expensive to run for every single query. But then you have frameworks like NREP over there in the top left. They prove that you can get really high accuracy at a low cost by using clever techniques, like trying multiple different ways of describing the database to the AI instead of just using brute force with a bigger, more expensive model.
And that brings us to the ultimate challenge. We have spent all this time and energy trying to get the AI to understand us perfectly. But what if our questions aren't perfect? Research from the Spinteract paper actually identifies 4 key types of human ambiguity. Sometimes the column is unclear. You say location, but do you mean the city or the state column? Or the desired output isn't specified. Do you want a count or a list of names? The question itself might be vague. Does most productive artists mean most songs or most sales? Or the value might just be stored differently than how we ask for it. So you see, the ultimate solution isn't just a smarter AI, but an AI that's smart enough to turn around and ask us for clarification. It needs to be able to start a dialogue. The quest for this perfect data translator is still going on, and you can see how it's evolved. From simple translation to self-correction to collaboration, and now, finally, to conversation. It's bringing us to a future where data isn't locked away behind a wall of code, but is accessible to anyone who just has a question. Which really just leaves us with one final thought. When that day comes and your data can finally understand you, what will you ask?